You did the responsible thing. You wrote code to keep your data clean. A little check before every insert. Does this already exist? Is this allowed? It ran. It went green. And your data is corrupt anyway, because you put the rule in the wrong place. You put it in your app, where 2 requests can slip past it at the same instant, and where a database restore can ignore it completely. A rule in your code is a suggestion. The Postgres manual is blunt about the approach you probably reached for, checking another table in your code before you insert. It calls it, and I'm quoting, very inconvenient with a number of problems. The machine wrote your integrity into app code, or into nowhere at all, because that's what the prompt looked like. But here's the difference that matters. A rule in your application is racy, bypassable, and gone the moment data loads out of order. A rule declared in the database, a constraint, is enforced by the engine on every single write, forever. Nobody can route around it. So the move that makes you a complete developer isn't writing better checks. It's declaring the rule once, in the schema, and never checking it by hand again. Failure 1, identity. Nothing on your users table says an email has to be unique, because nothing in your prompt said one person, one account. So the same customer signs up 3 times and all 3 save. Green, green, green. Now your customer count is wrong, your revenue per user is wrong, and a refund post to the wrong row. The fix is one declared rule, a unique constraint, which just means the database will not let this value repeat. Add it, and the 3rd signup is refused at the door. You didn't write code to catch duplicates. You told the schema duplicates can't exist. Failure 2, the link. An order belongs to a customer, but no foreign key connects them. A foreign key is the rule that says this order must point at a customer who actually exists. Without it, you delete a customer, and their orders are still there, pointing at a ghost, an orphaned row. It saved fine months ago. Then your nightly export reaches it and crashes. And the real cause is a delete from last week, 3 tables away. The docs say it plainly. This is maintaining the referential integrity of your data, and making correct use of foreign keys will definitely improve the quality of your applications. Declare the foreign key, and the database refuses the delete instead of leaving you a landmine. Failure 3, the invalid write that saves anyway. Nothing checks that a price is a positive number. Nothing says a required field can't be blank, so a price of -50 saves. Green. Nothing errors. But your dashboard number and your ledger number start drifting apart, quietly, and you find out at month end, or a customer finds out first. 2 more declared rules, fix it. A check constraint. A rule that a value has to make sense. A price has to be above 0, and not null. This field can't be empty. The database becomes the thing that refuses to store the lie. 3 failures, 1 move each. You named what must never be true, and let the engine keep it. Trap 1, the smart check. The AI writes a check constraint that tries to validate against another row or another table. Is this the cheapest item in the cart? Does this date come after that one? It looks right. It even works in your demo. But the manual is explicit. Postgres does not support check constraints that reference table data other than the new or updated row. So the day you restore a backup and the rows load out of order, the whole thing fails, and you lose data you were sure was guarded. The fix is in the docs too. For anything that spans rows or tables, don't use a check. Use a unique, an exclude, or foreign key constraint. Right tool, right scope. Trap 2, the foreign key that's secretly slow. You did everything right. You declared the foreign key. Correctness handled. But the docs warn about the part nobody reads. The declaration of a foreign key constraint does not automatically create an index on the referencing columns. An index is what lets the database jump straight to a row instead of reading the whole table. Without it, every time you delete or update the parent, the database scans the entire child table looking for references. Correct. And quietly crawling. It's the exact scale trap from the last episode, hiding underneath a correctness fix. So you add the index yourself, and use them sensibly. The docs remind you indexes add overhead. A complete developer declares the constraint and covers its cost. And here's the good news. Because this was never the AI can't. Researchers showed it can if you make it check its own work. Instead of asking one model for a schema, you use two. One module generates the schema. A second module hunts it for anomalies, duplicated data, tangled relationships, and sends the problems back. And they loop. Generate, verify, fix, until the structure is actually clean, guided by careful, task-specific prompts. A single naive prompt fails on the meaning between your columns. A refinement loop is what closes that gap. The future isn't handwriting every constraint forever. It's knowing what correct looks like well enough to make the machine prove it got there. So the habit is 3 words. Declare, don't check. Before you write a line of app code to validate your data, ask whether the database can declare the rule instead. And it almost always can. Then close the 2 gaps the machine leaves even when it uses constraints. Mark your required foreign keys not null, and add the index the foreign key didn't create for you. That's the difference between a schema that looks right and one that stays correct under pressure. And all of this keeps your data correct inside your own database. The moment it has to travel to a webhook, a queue, somebody else's API, a whole new kind of corruption begins. Thanks for watching. If this moved one rule out of your app code and into your schema, pass it to someone still validating data by hand. Subscribe to AI Tech Book. Next time, the glue, what happens when your correct data has to survive the trip to somebody else's system?